you might not know about. We're also going to talk about a cool thing is how can you let your app detect connectivity so you can actually progressively act on the user connectivity. And we're going to lightly touch web components because we're also using them, a bit of them. So, like as you know, progressive web apps is a big thing. We're going to just try to lightly go over it.
So let's take a look. What is a progressive web app? A progressive web app is not only one big thing, it's a set of different technologies, some of them really new, some of them really old, that are put together for one main goal, which is don't fail to the user.
Yeah, so we could actually talk all day long if you wanted to about progressive web apps, but we're going to refer the most important things about them. So progressive web apps should be responsive. They should be independent on the user connectivity, meaning they would work properly on really high-speed internet, what we call Li-Fi, like 2G really slow things, or even complete full-blown offline status.
Yeah, they are designed to be safe and app-like, installable and linkable and, well, easy to share.
Yeah, we're going to go through a bit of all those in the rest of our talk.
So the main concept here is to don't fail to the user. Historically, as a web developer, you had no control of what was happening over the network. And when the lack of network was there, when the user is offline, the user was left with nothing to play with.
And nothing is boring. People will not like that. People will leave your app, will stop using your site if you give them that. So we have ways of counterbalancing that.
So the philosophy behind it is the offline first. The offline first principle states that we are going to try to cache as many assets and as many content in the browser as we can, and as a first instance, show it. We are going to make a request over the network. We are going to see if there is new content there, but we are not going to wait on it. The first important stuff is to show content, valuable content to the user. And because this content that you have cached is better than nothing. In this way, the user is happy online, happy offline, and happy on slow networks.
One of the good things is on progressive web apps is performance. They're meant to be fast. Using these technologies, you can actually intercept requests that should go on either the browser cache or the server and act on it and respond with whatever you want. And because it's all in JavaScript, it's all programmable, you actually have full total control of what you can do.
So let's make a demo. Let's take a look to our experiment. Actually, if you scan this QR code, or if you go to adammodus.github.io, you will have access to our experimental app. We have to warn you, though, that because this is experimental technology, it might not work on all browsers.
Currently, we are supporting on desktop Chrome and all versions of up-to-date Chromium or Canary. We're supporting Firefox, and on mobile, we're supporting Android Chrome.
Yeah. So if you go there, this is more or less what you are going to see. It's a simple to-do list app. You have a menu here. You can add test to do, but yeah, we have also some mock data for you, so you don't have to waste your time. There is a to-do list, and well, once you have done something, you can just remove it.
Yeah, it's working on touch, so it could be handy for you on your phone if you feel like it.
So let's take a look also to one of the important aspects of progressive web apps.
Yeah. So because progressive web apps should feel and look like an app, that means your website or web app has to be installable, and for that you need to provide it on either desktop or mobile environments, an app name, an icon, and an app-like behavior.
So how do we get there? How do we provide all this information? Well, there is a technology called Web App Manifest, which is simply a JSON where you can list all this information. You say you provide different sizes for your icons. You say what's the short name of your application, so it will show on mobiles. You say which is the full name. You can say the author. You can specify a background color, which the browser is going to use while loading the assets. So when no CSS is there, this is the first background color that is going to be shown. And where shall our application start? In our case, the index HTML. This is not all of it. You have many, many more properties. Like if you are a game developer, you can say that your application has to be used only on portrait mode. So if you rotate your device, it won't rotate the browser.
The Web Map Manifests, when completely done, it can actually give you full total control of your mobile app, making it feel and work like a proper native app. You can see just on the video just a little bit of a small demo of our app being installed and working as a progressive web app on a mobile phone, actually my phone.
And the state of the art, can I use Web App Manifest? Well, this is a work in progress, it's a draft for now, and the main support is on Chrome. Firefox, I think they are not supporting it yet. So be aware that it's not something that you can put on production today and expect all your users to have.
Yeah, even the specification is not completely finished, so it might even change in the future. So yeah, keep in mind and keep up to date with the site.
So let's take a look to one of the core technologies of progressive web apps, service workers.
Okay, so what are service workers first? Service workers are actually a specific type of web workers made to work just with offline status, to handle offline status. They can cache your assets, they can give you a lot of control, and since they're JavaScript, you actually have complete control, like I said a while ago, to do whatever you want with the fetch requests and all that. You could even, if you want, always return a offline status web page to the user. It's better than nothing. It's better than what we call the white screen of death with the T-Rex.
Yeah, so this is a core technology and is really important and really exciting. And while learning it, I was on Udacity on a course, and I saw one video that the people of Udacity made to show how important is this technology. So why not? We are going to play it.
Not only how important, but also how cool it is.
For too long, users have been left staring at a white screen. For too long, they've been let down by the cruel seas of network connectivity. And for too long, we've been powerless to help. We've been left waiting. But no longer. A new browser feature has arrived. A total game changer. A feature that lets you control the network rather than letting the network control you. Who is this new feature? And what promises does it bring? Introducing the service worker.
Get excited.
Okay, so I guess the next step is to show me a hello world.
Yeah, like all programming first baby steps.
So we prepared something here. This is going to be our demo scenario. We have here a small Node.js server serving our assets. And while we load our application, it's going to register what are we requesting over the network. So if I do a refresh now, it's going to show all the CSS, JavaScript, SVGs, and anything that I request over the network. As a hello world, we placed a simple interceptor that what it does is really nothing. It gets any network request that you place on the browser, and it shows you some stupid content. So if I reload now this page, it just shows an SVG, and well, it shows that we don't have, or we might not have, internet connection. So actually, if now I stop the node server and I reload the page, the content is still there. It only complains that, well, the browser cannot find the network there. So let's start again our server. Okay, so I guess the next step is to tell how to play with service workers, how to develop them. In Chrome, you got a Chrome service workers internals page that allows you to inspect the code of the service worker, so you can debug it on the Chrome DevTools. But also, because the service worker gets installed in the browser, you can stop it and also unregister it. So when you change the code of your service worker, you can get the new instance installed.
Yeah, like we said a while ago, full, total control of everything.
Okay, this was a nice hello world. Let's see a bit more about service workers.
So, since service workers are part of the Progressive Web Apps new set of technologies, the main thing right now of the bats that you have to take into account is that they have to be safe, meaning that service workers will only work on HTTPS or what is considered safe connections. Other than that, of course, when you're experimenting, it will work on localhost, but if you're trying to make a public website, it has to serve HTTPS. Other than that, you can see actually a little snippet of code here of us registering the service worker on your browser. And keep in mind, we are adding the scope. And what is the scope? The scope should actually match the service worker location and is going to tell the service worker we are registering, what file system path does he have access to, so he can cache files or assets under that file system or file path. Meaning that with this, you can actually have, if you want to, multiple service workers, each of them specialized in a different part of your app, if that makes sense to you. I'm not to judge.
So you can see that you define what should you cache in a really simple array of assets that are under your scope.
Yeah.
And well, service workers as itself, as a web worker, it has a life cycle. Mainly the story here is that when the service worker gets loaded, it tries to install itself and start looking for all the active service workers. When the service worker is sure that the other ones are not intercepting the network calls or requests of the browser, it gets activated. When it gets activated, it checks for old caches and try to load all the assets that it has to load. It makes sure that it's up to date and that you have the last content. And then it gets activated and idled. So it means that any request the browser makes over the network, it can be intercepted and it can be replaced with content that we have cached, or we can cache new content.
Yeah, that is actually the main life status of the service work in which it will spend more time. Other than that, you can actually manually, using code, terminate your service worker if you require it by any chance. Or also, if the service worker is not doing anything anymore, the browser can choose to actively terminate it at a point in time and resuscitate him when required.
Yeah. You can also get an event that your service worker is not going to get activated because another service worker in a more important path is replacing it. So let's take a look a bit to the code. Let's go to our index and use our created service worker instead of the hello world. So mainly what happens here is a feature detection. We detect that we support service workers. And then if we look to the service worker file, it's just what we showed previously. It's a list of assets to be cached. And there is a specific event that we are going to take a look to. That is when we fetch over the network, see if the cache match. So if we load this service worker in our web application, what we are going to see is over the server that first we downloaded all the assets like we would do normally. So all the style and everything. And then at some point, the service worker was served over the network, and we detected the support on the browser, we registered, we installed it, and we activated. And when the service worker got activated, what it did is make sure that it has the last resources. So the service worker itself went through this list of assets to cache and made sure to ask them to the server. This is only happening the first time because now we install it. So if now I clean the terminal and I reload our web application, everything is cached, everything is intercepted, but the service worker itself. The service worker is always being requested to the server for a reason that we will show you in a bit. Mm-hmm. So what we can see here is also this event, the fetch event. So what happens is that we get a network request, and we are going to ask to our cache, do I have this resource? And if so, we are going to load it from our cache. If not, we are going to preemptively cache it. And this is what you can see here in the yellow service worker console log, that we intercept the assets, and because the cache was hit, we are serving it from the cache. Okay, so this is mainly how the service worker works and how it caches all the resources. But now we have a web application that every time that you reload, doesn't matter if the server is offline, you get a certain set of assets. You get a CSS, you get HTML, you get JavaScript that makes your app usable and functional offline. But what happens when you want to deploy a new version? How do you control the cache invalidation?
Yeah, because let's say you work on a major website, you got millions of people hourly going there, and there is a bug on an asset. Let's say there's a JavaScript issue, like a typo. It's a very common thing. How do you force the user to invalidate his cache so he can lose the buggy assets and start using the new ones? Well, the service worker actually allows you to do that using a version system. The service worker version actually will tell the user what he is, meaning that if the version changes, the user, if connected online, will automatically get all the new assets and the new service worker, because even your service worker could change itself, which is, I think, extremely useful for those scenarios. You can actually set what we did here. We are using a numbered version, but also today's date. So by default, we're actually making the user reload everything every single new day he accesses our websites. But if he goes 20 times to the website on the same day, he's only always going to get the same cached assets.
So let's try this out. Let's change the version of our service worker. And what is going to happen here now, if we start the server, is that the service worker is going to request to the server the file service worker, is going to see that there is a new version, and automatically is going to request all the resources to the server, all the new assets. So we reload the page. The service worker was the first one being served, and it says, hey, I have a new version, so I have to go again through all the list of my assets to cache, and I have to be sure to request them, so I have the latest version on our browser cache.
Making sure the user is always up to date when you want him to.
Okay, as an endpoint for service workers, let's take a look at the current state. This is a finalized standard. Chrome and Firefox support it and is implemented already. Microsoft is implementing it, and WebKit is also promising to implement it, and they are working on there.
Yeah, also, that's nice. It's also working on Android and Chrome on Android, which is also pretty useful already.
Okay, let's move on to our next technology that enables progressive web apps.
Okay, so on our app, we're using something called IndexDB. We found it actually to be a very nifty little browser feature that a lot of people don't know about, and we want to share our thoughts about it. What is IndexDB? IndexDB is actually a real database on your browser. It is made for document storage, and is actually a very, very good alternative to a lot of the local storage abuses, because throughout the years I've been seeing people use local storage for everything they want to store. And local storage is just a key value storage system. And while IndexDB is actually document oriented, meaning you have a lot more freedom in what you want to actually save there, but much like local storage is public. So please do not ever cache anything that's sensitive or should be secret in any way there, because a good developer will be able to find that out very easily in a way I'll show you just in a bit. IndexDB will allow you to perform CRUD operations, and much like what we call normally a proper database, it actually allows you to set up a data schema and add indexes to perform faster queries. So you can actually have several thousands of documents there, and if you have a proper data schema and indexing, you can actually make it extremely fast, so you can always keep the user as not waiting for anything. Also, a really nice little feature, it supports database version upgrades. So let's say you're developing and you just change your database schema for something that's much better and faster because business changed. Well, there's ways of going around that and making sure that your website is always up to date and will not fail on any instance. And in our particular app, we're saving the to-do and the little information you see on our little to-do lists, all on IndexDB.
Yeah, so as you can see here, if we show some mock data, you will see the new assets being created. And if you go to application and you take a look to the IndexDB, you can see there our to-do items. Yeah. So you can always manipulate it, clean, or see what's happening on the IndexDB of your browser on the Chrome DevTools.
Yeah, also keep in mind what you're seeing here is not all of the attributes of your documents. It's only the attributes that you're set as a key path, meaning you have to be unique. You're also able to get information here and perform queries here. So once again, keep in mind, do not store sensitive information here, because I can just go on Chrome DevTools and look it up.
Yeah. Okay, let's take a look at the state of the art of IndexDB. We can see that it's a really mature technology. It's supported mainly everywhere. And this is going to be the future technology of how to store user information on your browser. Because there have been over time many other technologies that allowed you to store information, but the browser makers couldn't not agree on what to, which technology to be standard, or they were not future-proof.
Yeah, being such a mature technology, it actually exists more time than you probably think it does. So do not feel afraid of using it. It's actually pretty simple, and it works really well on a lot of devices.
Okay, so let's move on to the next topic, detecting connectivity. And here, while developing our experiment, we found out that a lot of browsers already have a flag called a navigator online and event when the browser goes online and offline. But this, for some makers, is deprecated. Some are not going to implement it anymore for one reason. And is mainly that they cannot agree on what's happening on how to detect that the browser is offline. You could be connected to a Wi-Fi, and this Wi-Fi don't have internet access. Or you could be connected to an Ethernet and, or to a GSM network without actually data in it.
You can even have internet and the server you're trying to access is offline, and that's still kind of an offline status for your particular app.
So what we implemented as a first approach is an event listener that is going to listen to these events and notify to the user when it goes offline. So for instance here, if on the network I faked that I'm offline, the user is going to get a notification, oh, you got offline. And the status text is going to switch to red. If I go again online, we are going to notify, okay, you're online again, safe to go, and the text is going to become green.
Yeah.
The big UX design pattern to follow here is always to keep the user up to date on what's going on, what your application can do offline, and what's going to happen when the user gets online again. For some applications, you will have to leave the user without not much functionality, and you can provide them with maybe a crosswords game like the Guardian UK is doing. And for others, you can just show the cached information and update with the newest information when you go online again.
Yeah, it is part of the offline first attitude that we talked about. And as you can see, telling the user something when he's offline or online, notifying him, tends to be very, very useful information. And it will always be better than not telling him anything and just the browser or the website start acting weird or buggy, or because the user doesn't know. Maybe he could maybe not know that he's offline, and telling him of that is typically very, very useful.
But this is not enough. In your application, you have to look for network failures or for a long network delay. Because imagine that your cell phone is connected to a Wi-Fi, but the Wi-Fi has no internet, or just the GSM connection is really, really slow.
Yeah, like you're in the middle of the ocean.
Yeah. So one approach to take here is try on the AJAX request to load a resource, and if it fails or if you have a timeout, try it again. And probably if this fails, you are offline or you are having connectivity issues, so you can already notify the user something's going on with your connection. Don't worry, you can do this offline, and when you are online again, we will take you to the full functionality again.
Yeah. Not to be repetitive, but again, full total control of the user status and how things are at the moment, so you can act on it and progressively make things better for the user.
And a bit the state of the art on the events when the navigator is online and offline. It's really well supported, but some browser may stop implementing it as Microsoft considers that is a deprecated technology.
Be careful.
And the last technology we want to talk a bit about it is web components. And web components are not only, again, one technology, it's a set of technologies that allows you to create your own HTML tags to modularize and express better with the syntax what things are. So in our example, what we did is for the to-do card, we created a web component for it. So if you look to the HTML, the tag for it is to-do card, and you can, via attributes, provide the identifier, the text, the title, and anything that you need. This is really cool because how it's implemented is just a class that is going to be your new web component that extends directly from an HTML element. And in our case, what we do while initiating this element is we check for the support of Shadow DOM and the support of template. And well, if Shadow DOM is not support, which is the case of Firefox, if you don't enable the flags, we are just going to load it from a template and show it as a HTML element.
Meaning that if you act on it, you can either implement the web component using shadow root and all the cool new tech, but if the browser does not support it, you can actually make it work as well, just not using all the cool new tech, but still working for the user, no loss of features, no loss of functionality.
Yeah. One last thing I forgot is in Application tab, you can actually see the information about your manifest. You can see what you are providing in your manifest JSON. So all the icons that you're caching, the name of your application, the short name, and any tag.
Also, for the developers using service workers, you can go to your console and you'll be able to see and test things on different contexts. So here on sources, where did you get? Where should you change the contexts? On here, you can actually change the context of what you are. So this is our web worker. So here I can test all functions that are available on the web worker and debug or do whatever I want. And with this one here, I can go into my service worker and actually tell me that the service worker is installed already. Meaning that even for debugging purposes, at least Chrome DevTools, which is our main tool right now, supports this completely, and you have actually no problems debugging or testing parts of your app using this tech.
Okay. Well, taking a look to the support again of web components, you can see that there are a lot of technologies there, and all the browsers have their own roadmap. So if we take a look to the Mozilla page, you can see the specific technology that, as I said, is web components and the status of it. And you can click and go to see what the browsers are implementing and supporting already. Yeah. Also, in webcomponents.org is a great page to see also the browser support, and to get all the polyfills that you may need today to make web components work everywhere.
Yeah, keep in mind that web components, like Antoni just said, is not just one technology, it's actually a set of different things. So part of your web component might work, part of it might not work. Use that Mozilla or any other website, it will give you an up-to-date status on how things are implemented and supported. And it's actually a big, big world for web components. Much like progressive web apps, web components are a big thing. We could make a day-long talk about web components and a day-long talk, or maybe even more, about progressive web apps. We're just barely scratching the surface. There's a lot of cool things there. There's a lot of cool things to explore, to try out, and to make, just create things with it.
So we are heading up to the last slides. Are there any questions?
About the IndexDB, do we have control over the storage limit of IndexDB, or how does that work? With the IndexDB, do we have control on the storage, like the amount of storage on the IndexDB, or is that something that the browser does?
There are some properties that you can read on the browser, and you have some warnings. You can listen to some events that will tell you that your space is getting up, and I think the specification has a max limit, but I don't remember exactly which one it is. But on mobile browsers, the limit is lower than on desktop, for instance. And maybe Mozilla decides that can give you more space, or maybe Chrome another one. But the API defines callbacks and events to warn you and to inform you of how much is available there.
Yeah, exactly. And do keep in mind that IndexDB is a database on your browser, so it shouldn't be a full-blown database with like all the backend stuff and all that. It should just record things that are useful to show to the user, and the user might require to see later.
Yeah.
What about data synchronization with the server? For example, if your app requires to save the to-dos not on IndexDB but on the server itself, how can it be done with the service workers? Or can service workers be used for that, for example?
What you could do is, well, as Rafa told, you have tools like upgrading your database when it gets not in sync, or when you release a new schema. But what you could do is proactively, when you get online again, try to send the information that your user had been working on, and well, if there is no issues adding this new information to your server, then you tell to the user your information is online and available everywhere else. And otherwise, if you get an error, if you get an issue, you may want to think about why did this happen, why the offline information is not suddenly compatible with a new entry. And could happen that applications like Twitter say, I cannot determine which tweet should go before or after, and ask you what to do, or tell you that, sorry, we cannot update the information, it's not compatible with what we have online, with what somebody else was working on online, and your changes may be deleted, so you will have to rework on it. This is the worst case, but that you should avoid.
Yeah. A TLDR kind of thing for that would be on your service worker, you can, on the browser, act on the on-online and on-offline events. So when the user loses connectivity or gains connectivity again. And with that, you can do something with your service worker or with the browser itself with your JavaScript. With the service worker, you can act on updating the service worker version. So like we talked about a little bit ago, it'll recache all the assets when that happens. On the IndexDB, you can also upgrade the IndexDB version, meaning that it will run a specific event which is on upgrade needed, And you can, and on that happen, create either a completely new one and set your new data schema and copy information from the old one to the new one, or even change the current one as well. And that's possible as well. So yeah, those are like the keywords: the on-online and on-offline events, and the on-upgrade needed events on the database for your reference. Any other questions at all? No?
Well,
Okay.
then the last thing is the resources. For service workers, we are using this great GitHub repo, Awesome Service Workers. They have a lot of links and a lot of courses, and I found the Udacity course through them. And they have a quite active forum discussions about what's the way to implement things, what are the cache strategies to go for a certain application, and things like that. We are sharing our experiment on GitHub.
Yep.
And we are also going to share the slides soon.
Yeah. Also keep in mind, this app that we just made and show is only using a very, very simple Express node server. And every other technology we're using is completely web native. We're not using any SaaS, we're not using any framework, any library. We're going to make it as simple as possible for you to learn. So don't be afraid. Go there, check it out, clone it, tweak it, change it. Submit pull requests to me or to Antoni. We'll deal with it. Just use it to learn, and it's a sharing tool.
Yeah, and well, to the last slide, thank you for being there, and to Pixel Camps again to giving us the opportunity to talk here.
And we hope you had a good time.